All right, this is day 3, lesson 1.3, where we're looking at quadratic patterns. So when we take a look at a pattern, we've learned that we can have linear patterns. We know that a linear equation is written y equals mx plus b. The m is the slope. We have a constant slope, making the graph look like a line. So in a pattern like this one, we can see that we go from 2 stars to 4, 4 stars to 6. What is the pattern that we see here? We are adding 2 stars every step. This is a constant slope, adding 2 every step, making it linear. So if we go up or down by the same amount each time, we have a constant growth that is a linear function. Now, another function we've learned about is exponential functions. Exponential have also a constant growth rate, but this time we have a constant multiplier. For example, in this pattern here, from step 0 to 1, we go from 1 dot to 3 dots. So at first we may think we're adding 2 dots. But then from step 1 to step 2, we go from 3 to 9 dots. Are we adding 2? No, this isn't adding the same amount each time. Let's see if we're multiplying the same amount each time. From 1 to 3, we multiplied by 3. From 3 to 9, we also multiplied by 3. From 9 to 27, we also multiplied this by 3. So every step was multiplying by the same number. This is a constant multiplier of 3, an exponential function. Graphically, an exponential function looks like this, where it's constantly multiplying. The last function that is new for all of us is quadratic functions. These are neither adding by the same amount or multiplying by the same amount each time. So let's look at this pattern here. From step 0 to step 1, we went from 1 to 2 dots. So maybe we added a dot, or maybe we multiplied by 2. From step 1 at 2 dots to step 2, we went from 2 dots to 5 dots. We added 3 dots here, or we multiplied by 2.5. Is that the same growth rate from step 0 to step 1? No, we're not adding by the same number each time, and we're not multiplying by the same number each time. In fact, we added 1 dot, then 3 dots, then 5 dots. There must be a different pattern here. And we can take a look at this pattern. In step 0, we just have 1 dot by itself. In step 1, we have 1 dot and 1 dot next to it. Let's see if we can find a square pattern here. Here we have 4 dots and 1 dot next to it. See how we have a square of 4 dots. In step 3, do you see a square as well, a square of dots? In step 3, I see 9 dots, which is a square of 3 by 3, or 9 dots. So this is a squared pattern. In step 1, the square is 1 by 1. We have 1 times 1 is 1, and an extra dot. In step 2, 2 times 2 is 4, a square of 4, and 1 dot. In step 3, 3 times 3 is 9, and 1 dot. We know that a squared pattern, or multiplying this step by itself, is the same thing as having an exponent of 2. A quadratic pattern will have a squared term in the equation. We are squaring the step number. So at step 1, we have 1 squared is 1 plus 4 extra dots. Step 2, we have 2 squared is 4 plus 4 extra dots. Step 3, we have 9 plus 4 extra dots. We have a squared term in the equation, making it a quadratic pattern.